the factor which is most associated with drastic climate changes, things are getting worse fast, right? Climate change is primarily associated with carbon dioxide resulting from industrial activity. This gas creates an insulating barrier, trapping Earth's heat, thereby causing a greenhouse effect, which gradually warms the global average temperature. And this global warming is understood to be causing long-term changes in average weather patterns and a higher occurrence of natural disasters. Naturally, this information is cause for alarm. I mean, more global warming means more natural disasters, which means things are getting worse fast, right? Well, according to Our World in Data, the number of people affected by natural disasters peaked in the year 2000, but has trended down significantly since then, to less than those affected in the 1980s. Also, the number of deaths due to natural disasters has been on a steady decline since the early 1900s. Now, I'm going to show you some more perspectives in a moment, but I just want to let you know that at particular points in this video, I will be referring to information conveyed by the award-winning, Harvard-educated atmospheric physicist and meteorologist Dr. Richard Lindzen in a 2-hour interview he had with Dr. Jordan Peterson. According to Lindzen, if you look at Earth's history of changes in climate, the regions around the equator, the tropics, have remained relatively constant, while the temperature difference between the poles and the tropics has varied significantly. Today, the temperature difference between the poles and the tropics is about 40 degrees Celsius. 50 million years ago, during the Eocene, the difference was about 20 degrees Celsius. And during the Ice Age, around 2.6 million years ago, it was about 60 degrees Celsius. We also know that Earth has had at least 5 major ice ages, and during these periods, the global temperature of Earth decreased, which caused glaciers and ice sheets to expand. It is believed by many scientists that we are currently in an interglacial period where warmer temperatures have caused the ice caps to recede, but the glaciers may very well advance again many centuries from now. Earth has also experienced climate change over shorter periods, such as the so-called Little Ice Age, which lasted from around 1300 to 1850. This Little Ice Age caused average global temperatures to be 1 to 1.5 degrees Celsius cooler than they are today. Just as liking and subscribing causes you to be cooler than you were 5 seconds ago. In long-term climate change, the major factors influencing climate have to do with Earth's orbital cycles. They are called Milankovitch cycles, named after a Serbian scientist. Milankovitch cycles include the shape of Earth's orbit, its eccentricity, the direction that Earth's spin axis is pointed, its precession, and the angle of Earth's tilt with respect to its orbital plane, its obliquity. During these cycles, Earth's exposure to solar radiation varies, and this increases or decreases Earth's atmospheric insulation by up to 25% at regions on either side of the equator, or in other words, at middle latitudes. According to Lindzen, in the summer, the Arctic experiences a change of solar radiation exposure up to 100 watts per meter squared. Meanwhile, the warming greenhouse effect of CO2 is 2 or 3 watts per meter squared. So carbon dioxide does indeed contribute to warming, and the greenhouse effect is significant within the tropics. However, it is considerably less impactful on the temperature difference between the poles and the tropics, the factor which is most associated with drastic climate changes in the Earth's history. Another thing which influences the solar radiation we experience on Earth is the fluctuation of the sun's solar activity, as its magnetic field flips every 11 years. This is called the solar cycle, where the sun's north and south poles switch places. And when the sun's solar activity is higher, we feel those effects here on Earth as increased electromagnetic radiation to the Earth's upper atmosphere. And currently in 2024, we are experiencing a solar maximum when the sun's solar activity is at its highest. Earth also experiences regular changes in climate thanks to a phenomenon called Niño-Southern Oscillation, or ENSO for short. ENSO is a cycle which consists of 2 oceanic phases, namely La Niña, the little girl, and El Niño, the little boy, so named because it typically peaks in December, around Christmas time. In normal conditions, trade winds blow across the Pacific from east to west, and these winds bring warm surface waters with them. These then accumulate in the western Pacific, while the shallow waters in the eastern Pacific cool. But every few years the trade winds weaken, causing the warm surface waters to move back to the east, thereby warming the eastern waters once again. This process is El Niño, and it results in some dramatic changes in climate. Freak storms occur over the Pacific Islands and the west coast of the Americas, and flooding occurs in the southern US. Meanwhile, rainfall decreases in Australia and in southern Asia. Eventually, the east to west trade winds increase in strength once more, sometimes becoming even stronger than normal. When this happens, the warm water once again moves back to the western Pacific, but this time the waters in the eastern Pacific cool even more than usual. This is La Niña, and it results in unusually cold conditions in the tropical Pacific, leading to drought in the southern US and flooding in the Pacific Northwest. On average, El Niño and La Niña events occur every 2 to 7 years and typically last 9 to 12 months. El Niño generally occurs more frequently than La Niña, and when it ends, climate systems return to normal for a time. Now, let's talk about how scientists determine global average temperature. There are over 100,000 weather stations distributed across 180 countries, each of which compare the daily temperature to the long-term average for that location and time over a 30-year period. Deviations from the long-term average are called anomalies. These daily anomalies then form an average over the period of a month. The average monthly anomalies are then used by scientists to work out seasonal and annual temperature anomalies. But from what I can see, this approach of measurement is mathematically incorrect. I'll show you what I mean with math. Don't worry, it's not difficult, just bear with me. You see, the result you get from the average of several averages often is not the same result you get from taking one average of all original values. This is especially true if the count and the magnitude of the values vary greatly. As an example, the average of a dataset 3, 6, and 9 is 6. The average of a dataset 10, 20, 30, 40, and 50 is 30. If I then take an average of the averages, that would mean getting an average from 6 and 30, which is 18. But if I take an average of all the original values instead, 3, 6, 9, 10, 20, 30, 40, and 50, the result is 21. So this is a mathematically flawed method of determining the metric for global mean temperature. And when these errors are used in projections of climate change, they become unreliable and enlarge over time because new errors are propagated from previous errors and so on. Therefore, the fact that we use these projections to conclude that Earth will warm by 1 to 3 degrees and that this will have catastrophic effects on its systems is worthy of inquiry. A system eventually arrives at a major point of dramatic change when the possibilities available to the system to adapt are constrained, meaning that no other outcomes are possible. And so drastic change occurs at the snap of a finger, like a house of cards suddenly collapsing with the weight of one card too many. However, Earth's environment has countless degrees of freedom, so it can adapt and overcome these issues in a non-dramatic fashion. Again, according to Lindzen, this is why tipping points in the climate system are virtually unheard of. As you can see, climate change is a very complex topic with so many factors at play, several of them even happening simultaneously. So the degree of impact and the outcomes of climate change are very difficult to predict with absolute certainty. I do acknowledge a changing climate. I have personally noticed changes in my immediate environment as I've gotten older. I also definitely believe that we should do everything we can to reduce pollution, keep our planet clean, and develop innovative technology for the sake of living in a healthy, symbiotic relationship with Earth. I just think that it's beneficial to keep our heads on straight and that any news on the matter is worth analyzing. We humans are adaptable if nothing else, and I believe that, in time, humanity will overcome these challenges. I also think that green initiatives can achieve more success by applying a solution-based mindset of here's what we can do instead of this is a problem. After all, basing decisions on fear is far less constructive than basing them on rational thinking. At least that's how I see it. And following this, I'll have another video on the topics of war, energy, waste, and population, which you can check out here. So if you enjoyed this, make sure you've subscribed. And if you didn't like the video, let me know how I can improve. Otherwise, just share your ideas in the comments. Thank you very much for watching and see you again soon. Bye. Bye.